Hi guys! Welcome back to my channel. So our lesson for today is about chi-square test. What do we mean by chi-square test? A chi-square test, it is the test of significance. It is a test useful measure of comparing experimentally obtained results with those expected theoretically and based on the hypothesis. It was first of all used by Karl Pearson, and it is denoted by the Greek sign x squared. And following the formula, we have x squared is equal to the summation of the quantity observed minus expected square over expected. So this is the formula used in obtaining your chi-square test. Next, we need to discuss about the formula. So the formula, it is a mathematical expression representing the ratio. Okay, the ratio between experimentally obtained result and the theoretically expected result. It uses data in the form of frequencies. So we have here your sigma sign as the sum of your O is for the observed value and E is for the expected value. Also note that in chi-square test, if there is no difference between actual and observed frequencies, the value of chi-square is 0. And if there is a difference between observed and expected frequencies, then the value of chi-square would be more than 0. So a chi-square test, it can be 0 and more than 0. Okay, next is we have the degree of freedom. So in degree of freedom, in test, while comparing the calculated value of with the table value, we have to calculate the degree of freedom. So the degree of freedom is calculated from the number of classes. So therefore, the number of degrees of freedom in a test in one class is equal to the number of classes minus 1. Okay? So in chi-square test, we use the degree of freedom, or if we have 2 or more classes. So for example, we have 2, 3, 4 classes. We use the formula, the quantity R minus 1 multiplied by the quantity C minus 1. Okay, where R is for the number of row in a table and C is for the number of column in a table. Okay, next is we have here your contingency table. So the term contingency table was first used by Karl Pearson. It is a type of table in a matrix format that displays the multivariate frequency distribution of a variable. So meaning it involves 2 or more variables. So they are heavily used in survey research. Another is in business intelligence. Another is engineering. And lastly, we have here your scientific research. Okay? So in contingency table, they provide a basic picture of the interrelation between 2 variables and can help find their interactions between them. So that is the use of the contingency table. Determination of chi-square test. These following steps are required to calculate the value of chi-square. So first is identify the topic. The next is make a contingency table and note the observed frequency in each classes of one event. row wise. So for example, the horizontally values and the numbers in each group of the other event column. For example, the vertically values. The next is to state the hypothesis. So first is you need to set up the null hypothesis, and then you go with the alternative hypothesis. The next is statistical test used. So we use here your chi-square test. And the next is the level of significance and the critical value. So your level of significance is a given value, and the critical value is you need to find by the use of a given table. So the tables are found in our group page. I posted it a long time ago, so check it out. Next is the computation. In computing, we have to use 3 steps. First is to calculate the expected frequency. Next is to find the difference between the observed and expected frequency. Then next is to calculate the chi-square value applying the formula. So the value is ranges from 0 to infinity. The next is you need to make a decision. So when you are deciding, we take note that if the computed value is larger than the critical value, then you need to reject the null hypothesis. Then, if the computed value is smaller than the critical value, then you need to accept the null hypothesis. Let's try this example. Test the hypothesis that there is no significant relationship between the sex of the employees and their job satisfaction level. If in a certain company in Makati, the following results were obtained, use 0.05 level of significance. So what is the problem here? So we need to find the relationship between the sex of the employees and the job satisfaction level. The next is we need to obtain the value in each row and column. Okay, so for example, your male is, so 45 of them is low, 16 medium, high, 55, a total of 160. Then female, we have 9, 10, high, 10. So we have 29. Then you need to add up the row column. Row and yung column. The next, the solution. So first step is you need to state the hypothesis. So what is your null hypothesis? So based from here, your null hypothesis is there is no significant relationship between the sex of the employees and their job satisfaction level. Okay. The next is the alternative hypothesis. We have there is significant relationship between the employees, sex, and their job satisfaction level. Okay. Next, the statistical use is we used the one sample chi-square test. The next, the level of significance. So we have level of significance of 0.05 and the critical value. So first is you need to find the degree of freedom. So based from the given table, how many rows are there? Okay, so number of rows and number of columns. So the numbers of row is 2 and the number of column is 3. So we have 2 minus 1, 1 multiplied by 3 minus 1 is 2. So we got 2 as the degree of freedom. Okay, then need to find the critical value by the use of this 0.05 as this level of significance, and the degree of freedom of 2. So from this given table, what or where is your 0.05? So your 0.05 are here, 5%. Okay? Then the degree of freedom is 2. The degree of freedom is 2. Then 0.05. Okay, so we get 5.99 as the critical value. Okay? The next step is to compute. So how do we compute? So first is you need to compute for the expected frequency of each category. So how do we compute for the expected frequency? Expected frequency is equal to observed frequency from the horizontally, or the total from the horizontally. So we have the total here, horizontal, and then vertically. So you need to multiply this 2, and then you need to divide the grand total. Okay, so let's try. So what is the expected frequency between male over low? So your male is here, male. So the data are here, male over low. Okay, so what is the total of male? So we have 160. How about low? So we have 54. So you need to multiply them. 160 multiplied by 54. Then after which, you need to divide the grand total, which is 189. Okay, so we obtain an expected frequency as 45.71. Okay. Next is male over medium. So same procedure. What is the total for male? We have 160 multiplied by 70. So a total of 59.26. The next is male over high. So male over high. So what is the total for male? 160 multiplied by high, which is 65 over 189. So a total of 55.03. And then next is female over low. So female, a total of 29 multiplied by low, which is 54 over 189. So a total of 8.29. The next is we have female over medium. So your female is 29 multiplied by 70 over 189. So a total of 10.74. And lastly, we have female over high. So your total of female is 29 multiplied by 65 over 189. So you have 9.27 as your expected frequency. Okay? Okay. Then let's proceed with the second solution. So we apply this formula. Okay. So this is the solution for that. So first is you need to put all the observed values. So we need to wrote them like this. You start at the top, down, top, down, top, down. Okay? Okay. The next is the expected values. So from here, we have 45 as the male overload. We have 45. Then the expected values for that is 45.71. And here 9. So we have female overload. So we have an expected values of 8.29. Then here is we have male over medium. So we have expected values of that is 59.26 and female over medium 10.74, then so on and so forth. Then next is we need to subtract your observed and the expected value. So 45 minus 45.71, we obtain negative 0.71. Then next is 9 minus 8.29, we obtain 0.71. And then next is 60 minus 59.26, we have 0.74. 10 minus 10.74, we have negative 0.74. And next is 55 minus 55.03, we have negative 0.03. Then 10 minus 9.27, we have 0.03. Then we get the sum of this, we have 0. Okay, we also note that the difference between the observed and the expected value is 0, always. Then next is, we also note that the total of observed and expected frequency is your grand total, which is 180. Okay? Then after which, you need to square the differences. So what is negative 0.71 squared? So we have 0.5041. Okay, and so on and so forth. Okay, the next is you need to divide these values by this e. You need to divide 0 minus e squared divided by e. So what is 0.5041 divided by 45.71? We have 0.0103. Then next, 0.06. Okay, and so on and so forth. So that is how you solve it. Then after which, if you are done dividing the square of the differences between O and E over E, then get the summation of this. What is the summation? We have 0.13218. So therefore, this number now is the chi-square. That is how you obtain your chi-square. Okay, are you good? The next step is the decision. So what is your critical value again? So we have 5.91. So your 5.91 is greater than 0.13218, or your computed value is smaller than the critical value. So therefore, you need to accept the null hypothesis. Then your solution now, or your final decision now, is there is no significant differences between the sex and the job satisfaction level. So that is your decision, because you need to accept the null hypothesis. Okay? Good. We also have here the alternative solution for that. So if you don't want to make a table, you can use this solution. Okay, so we need to apply the formula here. So we have to use this. Okay, formula. Same. If you don't want to use the other solution, you can use this. But probably, I recommend it, or I recommend you to use the previous solution. It was systematically obtained. Next, so example. So in a survey conducted with college students of a certain university in Metro Manila on the issue of frat hazing, the following results were obtained. Do the responses of the two groups differ? Use the 0.05 level. The opinion. We have the sexes, male, female. In favor, 28 male, 20 female. Not in favor, 122 male, 140 female. Total, 150 male and 160 female. Total of in favor, 48, not in favor, 262. And the grand total, which is 310. Okay, so from the given table, how many rows are there? So we have 1, 2 rows, which is male and female. How about column? We have 2. You're in favor and not in favor. So therefore, we have 2 by 2 contingency table. Okay? Okay. The next is, we need to go with our solution. So first step is to state the hypothesis. What is your null hypothesis? So your null hypothesis, it talks about the responses of the two groups do not differ. Okay? The responses of the two groups do not differ. And your alternative hypothesis is the responses of the two groups differ. The responses of the two groups differ. The next is, what is the statistical test used? We use the chi-square test. The next is the level of significance. So the level of significance is 0.05, and the critical value, okay, first is we need to find the degree of freedom by using the formula, the quantity r minus 1 multiplied by c minus 1. Okay, what or how many rows are there? Okay, 2. And how many columns? 2. So what is 2 minus 1? 1. And 2 minus 1? 1. So 1 multiplied by 1. So your degree of freedom is 1. The next is, we need to find the critical value by the use of the table. So we have level of significance of 0.05, and then we have a degree of freedom which is 1. So what is the critical value? We have 3.84 or 3.841. It's either, but we only use 2 decimal places, so we use 3.84. Okay, next solution is the computation. So first step is you need to find the expected frequency. So how do we obtain that? Okay, so how many, or what is the expected frequency between male over in favor? So what is the total for male? 150 multiplied by the total in favor, 48, divided by 310. So we obtain 23.23. Next, female over in favor. So female is how many? Okay, 160 female multiplied by total of in favor, which is 48. So 160 multiplied by 48 is, okay, 24.77 as the expected frequency for female over in favor. Next, how about male over not in favor? So male is 150 multiplied by not in favor, which is 262 divided by 210. So we obtain 126.77. And female over not in favor is we have female, which is 160 over not in favor, which is 262 over 310. So we have 135.3. Okay? Okay. The next is apply unit 8 through table. So you need to solve now your critical value by the use of this formula. Okay, we solve it systematically, so we use the table. So we have here your observed value. We have 28, 20, 122, 140. Okay. The next is the expected frequencies. We have what is the expected frequencies between male over in favor. We have 23.23. Next, female over in favor, we have 24.77. Next, okay, good. So that is the solution for that. And the next is the differences. So we have 4.77, negative 4.77, negative 4.77, 4.77. So the summation of this is 0, and the square, and then the quotient between them. So we obtain your critic or chi-square test as 2.2459. So what is the decision? Okay, so we need to accept the null hypothesis. So that is how to do it. Are you okay? Did you understand the lesson? Good. Alternative computation. So we have here, first is you need to apply the formula, the summation of the quotient between this. The next is, okay, so that is how you do it. Next is, so the computed value is smaller than the critical value, so therefore you need to accept the null hypothesis. Okay. You need to try this on a sheet of paper to be passed on Friday. Are we good? That is how, or that is your assignment. And the next is we have the table.